Welcome back to the Nested Warren. Here, Clover the Cottontail and the wise Math Shiba are exploring a place where math lives as physical spaces you can walk right through. By the 5th grade, the mathematical goal shifts. You no longer have to calculate every single number you see. Instead, you learn to read a record of the math. We call that record an expression. It acts as an architectural blueprint, showing you exactly how a calculation is physically built, without forcing you to actually sit down and do the arithmetic. In the Warren, parentheses act like a dirt chamber. They take a sum, like 8 plus 7, and group it into one unified room. Symbols placed outside tell you what action to take. When a times 2 sits outside, the entire chamber duplicates. The physical shape and grouping of these numbers start to tell a story. You can see how one amount relates to another before you ever reach for a pencil to start adding. Let's build a blueprint from scratch. Suppose the instructions are add 8 and 7, then multiply by 2. The order of the words dictates the construction. Add 8 and 7 is the first step, so Clover hollows out the foundational room. Parentheses form the walls, locking the 8 and 7 together as one step. Next, multiply by 2. This happens after the addition, so a times 2 drops outside the walls. The expression duplicates into 2 identical chambers, side by side, leaving the numbers uncalculated. Let's try another sequence. We need to construct 10 less than 4 times 6. Checking the diagram, 4 times 6 forms our starting point. That builds the central room. The phrase 10 less than that requires us to take 10 away from that central room. We put a minus 10 on the outside. The way you speak the words translates directly into the architecture of the borough. The structure is just a physical record of the language. This structural translation becomes incredibly useful when you encounter massive numbers, the kind that would take minutes of tedious scratching to solve. How does 3 times the sum of 18,932 and 921 compare to the base sum? The addition problem inside the parentheses is a single room. The times 3 modifier out front multiplies that unified room into 3 identical chambers. Scanning the horizon, 3 identical chambers are lined up where there used to be only one. The expression is exactly 3 times as large. Notice what we skipped. We determined the exact relationship without ever adding or multiplying those giant numbers together. Recognizing structural patterns, like a multiplier resting outside a chamber, provides a direct path to understanding scale. Let's test this logic. What happens if we use the exact same numbers, but change where the architectural walls are placed? Check this diagram. On the left, we have 2 times the sum of 8 and 7, with walls around the entire addition step. On the right, we have 2 times 8 plus 7, with walls isolating only the multiplication. The digits are identical, but shifting those parentheses alters the entire layout of the problem. One doubles the whole sum, the other only doubles the 8. The structures are completely different. So here's the rule of the Warren. Build the expression to perfectly match the words and read its structure to compare scale. As the wise Math Shiba reminds us, read the structure, not the answer. The walls tell you what is 3 times what. There is no need to rush to the arithmetic. Leaving the math entirely uncalculated, how does the sum of 36 and 47 times 5 compare to the base sum of 36 and 47? I'll see you at the next bend.